Hi friend, welcome back to another project of FMT. So today we'll be discussing this will be a thorough discussion on banking and finance, where we'll be using credit card users churn predictions, right? You can read this thoroughly. So you as a data scientist at this bank need to come up with a classification model that will help the bank improve its services so that customers do not renounce their credit cards, right? So you need to identify best possible model that will give the required performance. So this is the data description according to the CSV file. Now there will be some terms that we need to know that is the revolving balance, average open to buy, average utilized ratio, and ratio between average open to buy and credit limit, and average utilization ratio. So these are nothing but the bank specific terms, so you can go through them if you don't know already. Now the very first step is importing the library. So this will help in making the Python code more structured and automatically. So or we can say the good code practice to comment everywhere, right? So libraries to help with reading and manipulating data, of course NumPy and Panda, visualization for Seaborn and PyPlot, to tune model and get difference matrix score and split data. So we have F1 score, accuracy score, recall, so all these we get from matrix. Now for train test split, again we import the model selection, right? And for cross validation score and all, to be used for data scaling and one hot encoding. So we again include pre-processing, right, for standard scaler, minimax scaler, and one hot encoder. To impute missing values, simple imputer. To oversample and undersample data, smooth we have, and random under sampler we have. Now to do hyperparameter tuning, so randomized search CB, to be used for creating pipelines and personalizing them. So pipeline we have sklearn.pipeline, column transformer sklearn.compose, to define maximum number of column to be displayed in a data frame. So pd.set option display dot max column none, right? To suppress scientific notation for a data frame, pd.set option display float format. So lambda that we have to help with model building. So sklearn.linear model, import logistic regression, sklearn.tree, import decision tree classifier, sklearn.ensemble, import all these things. Now from xgboost, import xgb classifier. So to suppress scientific notation, we have set option display float format. To suppress warning, we have warning, and to do it we have warnings dot filter warning ignore. Now loading data, churn equals to pd.read csv. So bank churner csv, I'll be providing this csv in the description as well. Now checking the number of rows and column in the data, so we have a churn.save. So this is number of rows and the number of column. If we check the data overview, so here you can see that in data we are having churn.copy. So this will help us because we will be not altering the main variable, right? So then let's view the first 5 row of the data. So data.head, so all these are the head of our data. So you can see how nicely it is. Now let's view the last 5 row of the data. So data.tail, so this is the tail of data. Let's check the data types of the column in the data set. So data.info we have, so this is the information that we have. There are null values in the education level and marital status. So 5 columns are of object type, rest all are numerical. Let's check for duplicate values in the data. So data.duplicated.sum. So here we have 0 duplicate data. Let's check for missing values in the data. So for missing values, we are rounding the values of data.isNull.sum. We are dividing it to get the percentage values, right? So education level has 15% missing values and marital status has 7% missing values. Now let's view the statistical summary of the numerical column in the data. So here we are doing data.describe, we are importing we are using t as well. So it will transpose the matrix and will return more values, right? So here we have all these values, right? So transpose matrix means the view, you can see that count, mean, all these are in column format, right? So the interquartile range, min, max, all you can see. Now there are few observation, you can go through them if you need this case study for your college preparation or college project, so you can obviously get them clarification from here, right? So this is nothing but the observation and is defining some points regarding this 5-point summary. So of course you can go through them, but for now I'm skipping it. Now data.describe include object, again a dot t, so here count, unique, top, frequency, right? So we are getting it from description. Now for I in data.describe include object.column, so printing unique values in, right? Now printing data values and giving the gap. So for example, first we are having unique values in attrition flag R. So these we have existing customer, these we have attrited customer. Now attrition name, we have attrition flag, that is int 64. Similarly in gender, similarly in education level, similarly in marital status, so on so forth, right? So there are some more observation on that, like most of the records are for existing customers, most of the bank customers are female, most customers are graduates, most customer are married, most customer lie in the income group of less than $40,000, most customer have a blue card, the data is imbalanced, like that. Now missing values like ABC value of income category can be considered and treated as missing values. So let's move forward to the data pre-processing part. So client num consists of unique ID for clients, and hence will not add values to the modeling. So data dot drop client number, right? Access equals to 1, in place equals to true. Now we encoding the existing and attribute customers to 0 and 1 respectively for analysis. So data attrition flag replace existing customer as 0 and replace attrited customer as 1. Here one thing to note is that the EDA and exploratory data analysis section of the notebook has been covered in multiple times. The previous case studies, yeah, of course we have discussed all these many times, like what is the EDA summaries, right? So you can refer it from our previous videos. Now the below function need to be defined to carry out the exploratory data analysis. So function to plot a box plot and histogram along the same scale. So this is the histogram box plot function, which will plot the histogram, right? Now similarly function to create labeled bar plots. So for plotting label bar plots, you can see the function detail, right? Here it is. Now function to plot stacked bar chart. So we are defining all the functions first, like function to plot distributions, right? Similarly if you call all these, so you will definitely get the plotted you will definitely get the plotted views, right? Summary of EDA: the data set has these much rows and 21 columns. There are null values in the education level and marital status. 5 columns are of object types, rest of all are numeric. Data cleaning: so client num column consists of unique ID for clients and hence will not add values to the modeling. So this column has been dropped. The target variable is encoded to numeric. Missing values imputation will be done after splitting and data. Now we have univariate analysis here. So we are creating histogram. So here you can see histogram for all the attributes, and we have some conclusion on that, so you can also go with them. Then we have categorical variable like gender, education level, marital status, right? Similarly we have y-variate analysis, right? We are doing attrition flags versus gender, we are using. So this is nothing but the description, like whatever you are visualizing here. So we try to make that clear in the statements. So if you need it to understand it better, you can pause the video, you can go through with all the points, right? Now distribution plot with respect to target. So here again here you can see that we are getting all these box plots for these attrition flag and attrition flag for here. Similarly distribution of target for target 0 and for target 1. That means old customers and for attrited customers. Now customers with less total revolving balance are the ones who attrited. Such customer must have cleared their dues and opted out of the credit card services. Now attrition flag versus average open to buy. So here we have, there is not much difference in the distribution for an attrited and existing customers. So attrition flag versus total transaction categories, again we are using distribution of target for 0, target for 1, similarly box plot for them. You can also see the interquartile ranges respectively. Less number of transactions lead to higher attrition. Yes, customers with less than 80 to 100 transaction or median transaction equal to 40 in a year should be more focused upon what? Attrition flag versus total transaction amount. So again, distribution of target for target 0 and similarly for target 1. So we are again having the box plot for them. So this is nothing but this one, the attrition flag versus total transaction amount, right? So again here, less number of transaction might lead to a less transaction amount and eventually leading to customer attrition. So on so forth. We are still doing this for a total CT changed and attrition flag, right? So you can see the box plot. Now customer who didn't attrite showed less of variability across Q4 to Q1 as compared to the ones who attrited, right? So this is for that. Now customer utilizing their full credit limit are the ones who didn't attrited. Less utilization of the values credit indicates inactivity of customers. So let's find the percentage of outliers in each column of the data using IQR, that is interquartile range. So Q1 Q3 data dot quantile 0.25, Q3 data dot quantile 0.75, IQR equal to Q3 minus Q1, right? Of course this is nothing but the interquartile range, that is 75th percentile minus 25th percentile. So lower we will get lower we can get as Q1 minus 1.5 into IQR. So finding lower and upper bound for all values outside these bound are outliers, right? So here you will get the lower as well as the upper. So now we are doing missing values imputation. So we will first replace ABC values with np.none in income category, then we will impute missing values in all three columns using mod. So data 1 equals to data dot copy data 1 income category dot replace ABC np dot none in place equals to true, data 1 dot is na dot sum. So here you can see that all we have. Now imputer equals to simple imputer strategy most frequent, x equals to data 1 dot drop attrition flag x is equals to 1, y equals to data 1 attrition flag. So splitting data into training, validation and test set. First we split data into two parts, say temporary and test. So x temp x test, y temp y test. So that is train test split. Similarly x train x value, y train y value, train test split for this. Now we got this x train shape, similarly x val shape and x test shape, right? So now we are imputing for education level, marital status and income category. So fit and transform the train data. Again fit transform for x train of these column, transform for x val of these column, similarly transform for x test of these column. Now checking that column has missing values in the train or test set. So here we are printing all these, like x train is na, then x value is na, then x test is na. So first we have x train is na if there is any, similarly we have x val is na, and similarly we have x test is na, nothing. So all missing values have been treated, right? Now columns we are taking as xtrain dot select data types include project category. For I in columns dot column, so print xtrain of I dot values count. So print star, so print, so this is nothing but the visualization. So we have like a female, male, that is for gender, similarly for education level, marital status, income category and card category. Now column we are having of object and categories, right? So again, if we print that, gender, educational level, marital status, income category, and card category. Similarly, again for object, detect object and categories, right? So this is for X test. So this is for X test, right? Gender, education value, marital status, and income category, and card category. Now doing the encoding categorical variables. So X train, X value, X test. If we print all these respectively, so after encoding there are 29 columns, right? So here you can see that 29, 29, 29. If we do X train dot head, again getting the top 5 values. Now building the model evaluation and criterion we have is model can make wrong prediction as predicting a customer will attract and the customer doesn't attract, predicting a customer will not attract and the customer attracts. Which case is more important? So predicting the customer will not attract but he attracts, that is losing on losing on a valuable customer or assets, right? Now how to reduce the loss? So that is need to reduce false negative, of course. So first let's create two function to calculate different metrics and confusion metrics, so that we don't have to use the same code repeatedly for each model. So we are defining a function to compute different metrics to check performance of classification model built using scikit-learn. So here you can see that the function, right? Now similarly we are using for confusion matrix on sklearn. Now if we do the model with original data, so models we have the empty list. Now model dot append, so we will be using logistic regression, bagging, random forest, GBM, that is gradient boosting classifier, ADA boosting, right, XGBoost, and decision tree classifier. Similarly we will print the training performance and the validation performance on the basis of all these models. So here you can see that training performance of logistic regression 49%, bagging 98, random forest 1, GBM 0.87, ADA boosting 0.82, XG boosting 1 or say 100%, D-tree 1 or say 100%. Similarly for validation performance, now XG boost has the best performance on the validation, followed by GBM and ADA boosting. So of course you can see the XG boost 100%, and here also 85% for the validation, right? And then the 85 for GBM. Model with oversample data. So before oversampling, count of level of yes and of no. So these are the label. After oversampling, count of level yes and no, and after oversampling, count of shape of the X train, train X and train Y, right? Now again empty list for all the scoring. So here logistic regression, bagging, random forest, GBM, ADA boosting, XG boosting, and decision tree. So again we will get the performance, but this time ADA boost has the best performance on validation, followed by XG boosting. Now model with undersampled data. So RUS, a variable that containing a random undersample of random state 1, X train, Y train. Your RUS fit resample X train, Y train. So if we check before undersampling, count of level yes, count of level no. After undersampling, count of level yes, count of level no. Similarly after undersampling, this would be the oversampling, the shape of train X and the shape of train Y. Now model empty list, again we'll do the same thing, logistic bagging, random, BGM, ADA boosting, XG boost, and decision tree. This time again we will get it, but ADA boost has the best performance, followed by XG boost as per the validation performance. So this way you can keep checking with your data, right? Like how you want to call your model. Now which model should be tuned? So here XG boost, ADA boost, and gradient boosting model have consistent and good performance for all the three data set. So we will tune these three models. We will tune these three models using undersample data, as it is giving better result. Sometime model might overfit after undersampling and oversampling, so it's better to tune model with both undersample data and original data. Now tuning xg boosting, so tuning with undersample data. So here we have this time defining model parameter grid to pass in random search cb, right? So here best parameters are, we will have all these. Now tuned xgb1, so xgb classifier, so this is what we have, tuned xgb1 dot fit. Now checking models performance on train set, so xgb1 of train model performance classification sklearn, so tune xgb1 xtrain un ytrain un, right? So we have this accuracy, recall, precision and f1. Similarly accuracy, recall, precision and f1. Tuning with original data, so this is the time we have. Defining model xgb classifier, so random state 1, evaluation matrix, log loss. Similarly parameter grid to pass in random search cb, so parameter grid, so n estimators, learning rate and subsample, right, from sklearn import matrix. So again type of scoring used to compare parameter combination, so this is what we have. Now best parameters are, so subsample, so all these skill, position, weight, n estimator, learning rate, gamma, all these. Similarly for tuned xgb2, right, so xg boost classifier, so you can compare the values with these. Now checking models performance on tuning set, so xgb2 train model performance classification sklearn xgb2 train. Now accuracy, recall, precision, f1 score we have. Checking models performance on validation set, so xgb2 validation model performance classification sklearn, so tuned xgb2 x validator y validation. Now tuning ADA boosting, so same way we will tune the ADA boost, tuning with first undersample data, so here we will get the best parameter. Similarly, right, then similarly for ADA boosting, and then we can check the model performance, then check the model performance on validation set as well. Now tuning with the original data, so the ADA boosting, if we perform with the original data, so here best performance, that we will get the n estimator, learning rate and all these. ADA boosting classifier, the variable the values here. Now similarly again for training set, for training set and for validation set, we will get the data. Tuning gradient boosting classifier, so tuning with undersample data first, so again with the same method best parameter r, we'll get it. Now for again gradient boosting classifier, so if we get the performance on training set, so we'll get it. If we get it for validation set, we'll get it. Now tuning with original data, so here for original data, so here with original data we'll get the best performer, best parameter again with the gradient boost and classifier, right, all these that we are defining. Now again the performance on training set, right, and the performance of validation set, so you can compare all these with your previous values. Now model performance comparison, so this time we are trying to print the complete data frame. Here will be all the xg boost train with undersample with original data, similarly for gradient boost and similarly for ADA boosting. So here you can see that if we talk about accuracy, so xg boost trained with undersample data, so the accuracy is 0.912. if we check with any other like gradient boosting trained with original data, so it is 0.96. if we talk about the highest one, so still we have ADA boost trained with undersampled data. So I think in every case the ADA boosting has the best performance in accuracy, recall, precision and f1 score. Now validation performance comparison, so this is on the validation, but here in validation you can see that, so still the highest I guess we have yeah, this is different this time. If we talk about accuracy, so the highest one is that with the gradient boosting trained with undersample data and gradient boosting trained with original data, right? No, but the highest is in with ADA boosting trained with original data, like that. So gradient boosting model trained with original data has generalized performance, so let's consider it as the best model. So let's check the performance on test set, so gbm2 test. So again for test, the model has given good performance on test set as well, right? Now we are printing the bar plot of for features importance, right, and for relative importance. So here if we talk about the direct description, so total transaction amount is the most important variable in predicting credit card churn, followed by total revolving balance, total transaction category, total relationship count, and total CT change Q4 Q1. So this is, you can see total transaction amount, then this one, then this one, and so on so forth. Let's use column transformer to build the final model. So basically we'll create two different pipeline, one for numerical column and one for categorical column. For numerical column we will do missing values imputation as pre-processing. For categorical column we'll do one hot encoding and missing values imputation as pre-processing. And we are doing missing values imputation for the whole data, so that if there is any missing values in the data in future, that can be taken care of. So first creating a list of numerical values, then creating a transformer to numerical variable which will apply simple imputer on the numerical variables, then creating a list of categorical variable, creating a transformer for categorical variable which will first apply simple imputer and then do one hot encoding for categorical variable. Now handle unknown, so ignore, allow model to handle any unknown categories, right? So this way we will then separate target variable and other variable like this, x and y. So let's first do some basic processing. Of course client num consists of unique id for clients and hence will not add values to the modeling. So x dot drop client num xs1 implies true. So x income category replace abc of np dot none and again implies true. Now encoding existing and attrited customer to 0 and 1 respectively for analysis. So y dot replace existing customer, y dot replace attrited customer. Now we already know the best model we need to process with, so we don't need to divide into three parts. Splitting the data into train and test set. So x train x test, y train y test. So train test split, we have x y test size 0.30, random state equals to 1, stratify equals to 1. So print xtrain dot shape xtest dot shape 708819 303919, creating new pipeline with best parameter. So model equals to pipeline steps, we have pre and preprocessor, GBM, gradient boost and classifier. So fit the model on training data, model dot fit xtrain ytrain. So again pipeline for all these steps. Now here are some business recommendations. So we have been able to build a predictive model that bank can deploy the model to identify customers who are at the risk of attrition, and that the bank can use to find the key causes that drive attrition, then based on which bank can take appropriate action to build better relation policies for customers, right? So this is some detail, you can also go through it. Now basic thing, we are performing EDA on it, that univariate analysis first we will check with this. So function to plot a box plot and histogram along with the same scale. Similarly then we will observe, we will have observation on this customer age. So histogram on the box plot, we are calling this by passing the data and the customer age, right? So here you can see that we are plotting this for customer age. So for customer age, similarly you can pass any other attribute, so you will get the box plot accordingly. Now the distribution of customer age is normally distributed with mean and median at 46 years. From the box plot we can see that there are a few outliers. Now observations on months on book, so histogram box plot data months on books. So you can see that this time this is month for months on book. Similarly for credit limit and their observation, similarly for total revolving balance and for their observation, similarly for average open to buy, right? Observations, MT change Q4 Q1 and the observations. Now similarly for total transaction amount and the observation, you can see the difference in the box plot, right? And the observations, right? Similarly for, and so on so forth. This way we are doing it for all the columns, right? And finally the credit limit, average open to buy and average utilization ratio is at right skewed, right? So open to buy means how much credit a customer is left with, and average utilization ratio, that we know that one minus open to buy divided by credit limit. Now similarly, now this statement justified that right is skewed for all three variables. So this time we'll do function to create a labeled bar plots, right? So this way we are defining the complete function. You can pause the video, you can go through it thoroughly, like how we are passing only column name and getting the plot, right? So let's plot the bar plot for dependent count again. So here you can see that these are the dependent count and the count we have. Similarly for a relationship count, right, and the count here again we have 3. For third we have 2305. Similarly for month inactive, 12 month, so here you can see that bar plot for that. Similarly for contract count, 12 months. So and similarly for gender, right? Similarly for education level, similarly for marital status, similarly for income strategy, similarly for card category. So this way you can study each and every attribute thoroughly, right? Because we have tried to give the conclusion or give the point from each bar plots, right? So I hope it will definitely help you in your case studies. Now in EDA, next thing we will do the bivariate analysis. So we are plotting the heat map, so where it is highly correlated and not highly correlated. So we can see the highly correlated, that is we can say this one, the 0.54. so this is for average open to buy, right, with average open to buy. Okay, attrition flag shows a bit of negative correlation with total transaction and total transaction amount. There is a strong positive correlation between month on book and customer age, right? Month on book and the customer age. So you can see here 0.79, of course, and there is a negative correlation of total relationship count with the total transaction amount, and similarly total transaction category, total average utilization ratio with credit limit, and average open to buy. Yeah. Next thing, function to plot stacked bar chart. So again we are defining the function, calling the function, passing the values. So here you can see that, so there is not much difference in attrition percentage for the male and the female, as 20% of both males and female are attrited. Yeah, almost. Attrition flag versus marital status, again calling the function, you can see the observation for them. Similarly for education level, similarly for income category, similarly for attrition flag versus card category, right? Similarly for attrition flag versus contact count, 12 month, right? Attrition flag versus month inactive, 12 month. So I know whosoever my friends are working in the banking sector will definitely find this notebook for their reference. I know I'm not describing it in thoroughly because this is a big or too long to discuss, so the video will be very lengthy. So I'm just trying to give the points, like how we are framing the video, or how we are framing the content that can help you. Now attrition flag versus total relationship, again you can see that same function we are calling multiple time, but that is on different values. So you can take it as whatever you want from your data, right? So similarly so on. So similarly for attrition flag versus dependent count. Next thing we are doing function to plot distributions, right? So again you can see that we have defined a function at once, so you can see the function thoroughly. Then we are calling the functions for a desired column. So like we are calling the function for attrition flag versus customer age. So here you can see attrition flag versus customer age. Similarly for box plot for that as well. Same for attrition flag versus months on book. So attrition flag on months on book as well as the box plot. Similarly for attrition flag versus credit limit, attrition flag versus total revolving balance, attrition flag versus average open to buy, and attrition flag versus total transaction count, right? Attrition flags versus total transaction amount, attrition flag versus total amount Q4 Q1. So we have done this thoroughly, but the only thing is you need to sit down on it and you need to keep find what the exactly you want for your case study or for your specific problems, right? So this is similarly for attrition flag versus average utilization ratio. And now we are about to end of the video, so let's discuss few more points like what here we are doing. So again, columns, we are taking data of credit limit, credit total transaction amount, average utilization, and this we have the customer age. So right, and this is for credit limit, this is for total transaction amount, and this is for average utilization. So this is nothing but a line plot. So this is nothing but the subplot with line plot. So with age, the credit limit of male customer increased till 50 year, but for the female customer the credit limit constant throughout. Now although the credit limit for female customer is less, the total transaction made by them for all age groups is the same, and female customer utilize their credit more as compared to the male customer, where utilization dropped from 30 35 years but increased after 60 years. So this way you can conclude your case study or your specific problem. Hope this will definitely help you in the project, or if you are working in the field like in proper banking or finance sector, so this will definitely help you to visualize your problem. Hope this video helped you a lot. Please do like, share and subscribe. That will motivate us to come up with more content, more videos or more case study which will help you with your specific problem or specific task. So see you guys, have a good time, take care, all the best.